Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. So this is part 5 video on the chapter of direct and inverse proportion where I will solve the problems of the exercise 12b from the textbook of author RS Aggarwal, which is based on the inverse variation. So this video is part of the playlist CBSE Maths for class 8 following the textbook of author RS Aggarwal. If you are new to my channel or not yet subscribed, and if you are watching my videos regularly and my videos are beneficial to you, then I strongly suggest and request that you please support me by subscribing to my channel, and also please do not forget to press the bell icon so that you will be notified by my future videos. So let's get started in solving the problems of exercise 12b from the textbook of author RS Aggarwal on the chapter of direct and inverse proportion. Okay, so as you can see, I have my canvas on the right hand side, and I have written down all the problems from the textbook. So there are 15 problems. Uh, my machine is running a little slow. Anyway, so uh, here are the questions. Uh, Okay, so there are 15 questions, and as I always say, that after solving a set of problems, either from the exercise from the textbook or any mock test you are giving, or you are solving any problems from any reference book, always at the end of solving the problems, try to revise all the key concepts and formulas that you have used to solve the problems. This will always help you to so that the concepts and formulas will remain in your mind for a longer time, and this will also provide a good revise of the previous chapters. Okay, so let's start solving the problems. The first problem says that from the table below, find whether x and y are inversely proportional. So we are given a table of corresponding values of x and y. We know that if x and y, if the two quantities varies inversely with each other, then the product of the corresponding values must be equal. So we need to check. So let's see what is the product of the first corresponding value. So this is the first corresponding value. 6 into 9 is equal to 54. Because we know that if two quantity x and y vary inversely with each other, we know that the product of the two quantities always remains a constant, and this constant is known as the constant of variation. So for this table, if the if indeed the quantities x and y are inversely related to each other, then the constant of variation will be 54. Now let's see what is the product of the values, corresponding values for the data, for the second data, that is 10 into 15. Now definitely 10 into 15 is 150, which is not equal to 54. So right away we can say that this table, the data, as per the data, of the quantities x and y, we can say that the quantities x and y are not inversely related to each other, because their product, the values for the first corresponding values, the value of the product is 54, and for the second corresponding values the product is 150, which is not equal to 54. So we can say that x and y are not inversely proportional, and I use the symbol, this symbol, to mean that two quantities are not inversely proportional. Okay, so for the part 1, the quantities x and y are not inversely proportional. Also you can also check for the other corresponding values. 14 multiplied by 21 is definitely not equal to 54. Also 16 multiplied by 24 is not equal to 54. Okay, let's see the second table. So the concept is same. We will find the product of all the corresponding values, and then we will see if the product is coming out to be equal or not. So for this data, that is for the first corresponding values, we see the product is 5 multiplied by 18, which is equal to 90. Okay. Now for these corresponding values, we see the product of the corresponding values, that is the product of the quantities x and y, 9 into 10 is also coming out to be 90. So far so good. Okay. For these corresponding values, we need to check whether 15 into 6, this is also 90. This 3 multiplied by 30 is also equal to 90, and of course 45 multiplied by 2 is 90. So definitely we can say that x varies inversely with y, and we can also say that the constant of variation is equal to 90. The constant of variation is equal to 90 because when x and y, two quantities x and y, are inversely related to each other, we know that x, y, their product is a constant. The product is a constant, and in this table for this data we can say that the constant of variation or constant of proportion is 90. Okay, let's see the third table. For the first corresponding values, we see 9 multiplied by 4 is 36, and for the second corresponding values, we see their product 3 multiplied by 12 is also coming out to be 36. And for the third corresponding values, we see the 9 into 4, 6 into 9 is equal to 54, which is not equal to 36. Right away, now we can say that the data quantities x and y are not inversely related, since we have found one corresponding values, that is 6 and 9, whose product is not coming out to be equal to 36. And of course the last corresponding values is also coming out to be 36, but because of these corresponding values, we can say the table does not correspond to the fact that the quantities x and y vary inversely. If in a given table, if it is said that the quantities x and y is inversely related to each other, then all the corresponding values in the given table, their product must be equal, must be same. Okay. Problem number 2. If it is given that x varies inversely with the y, then find the values of x1, x2, y1 and y2 in the table below. So since x and y it is given that x and y are inversely related to each other, so the corresponding values, the product of the corresponding values must be equal. So we must have 8 multiplied by y1 should be equal to x1 multiplied by 4 should be equal to 16 multiplied by 15 should be equal to x2 multiplied by 2 should be equal to 80 multiplied by y2. So this is so we can clearly say that this value 16 into 5, this is the constant of variation or proportion, which is 80. So for this data or table, the constant of proportion or variation is 80. So now we can say that 8y is equal to 80. This implies y1 is equal to 80 by 8, which is equal to 10. So also we can say that 4x1 is equal to 80. This implies x1 is equal to 80 by 4, which is equal to 20. So we have got y1 is equal to 10 and x1 is equal to 20. Also we know that 2x2 should be equal to 80. So this implies x2 is equal to 80 by 2, which is equal to 40. So we have found x1, x2, y1. Now we have to find y2. Now we know that 80 y2 should be equal to 80. This implies that y2 is equal to 80 by 80, which is equal to 1. So basically, by equating the product of all the corresponding values to equal to 80, since we have already found 80 to be the constant of variation, because uh, from these corresponding values where both the quantity of x and y are given, we can clearly find out what is the constant of variation. The constant of variation will be the product of the x and y value, which is 16 multiplied by 5, which is equal to 80. Now to find all the other unknowns, we will multiply the corresponding values and will equate that to 80, and we will solve for the unknown values. Okay. Now we will solve some word problems, which are the apparently these problems, if you can understand the quantities and whether they are varying each other inversely, that is the main task. Okay. So if 35 men can reap a field in 8 days, in how many days can 20 men reap the same field? So in the previous video, that is part 4, where I discussed about inverse proportion, I mentioned some examples. There I cited one example, that is men, work and time. That is a number of men is doing a constant amount of work and the time taken. So if the amount of work is constant, then the number of men completing that work and the time taken, that is the number of days to complete that work, these two quantity will be inversely proportional. So in this problem, the field is the constant factor. That is, the amount of work is related to the field. It is the same field. The field is not changing. So if reaping the same field, so this is the constant factor. That is, you can relate reaping the same field as the constant amount of work. So this is constant. This part is constant. Since this is constant, if you consider x as number of men and y as the number of days to reap, number of days required to reap the field, then clearly we can say that the quantities x and y will be inversely related to each other. That is, x and y are in inverse variation. The concept to understand is that the amount of work is constant. That is, the amount of work in this problem is reaping the same field. That is the constant amount of work. So now if you tabulate some data, then we tabulate the data of x and y from the given from the problem, and we solve for the unknown. So we have x and y. It is given that 35 men can reap a field in 8 days. So we have the first corresponding values. So 35 will be the value of x, and 8 days, so 8 will be the corresponding value of y. Now it is asking in how many days can 20 men reap the same field. So you can say that let in y1 days 20 men can reap the same field. We are assuming that 20 men will reap the same field in y1 days. So we can enter the data 20 for x and y1 for y. Now we will apply the concept, we will apply the formula, that is 35 multiplied by 8 should be equal to 20 multiplied by y1. So this implies y1 is equal to 35 multiplied by 8 divided by 20. So this is 4, 2, 4, 5, 5, 7. So this is equal to 14. 14. So y1 is 14 days. So the answer is 14 days. So 20 men will reap the same field in 14 days. Now always after solving a problem on direct or inverse proportion, always check whether the data is correct or not, meaning that you know that if when x and y are inversely related to each other, if you increase x, y will decrease, and if you decrease x, y will increase. So when x was 20, it is less than 35. So definitely y1 should be more than 8, and indeed we have found 14 days 14 is more than 8. So this way you always check the consistency, the correctness of your answer. Okay. Problem number 4. 12 men can dig a pond in 8 days. How many men can dig it in 6 days? So this problem is similar to problem number 3. That is, a certain number of men is doing a constant amount of work in certain time. So the time and the number of men are the two main quantities that are varying inversely with each other, provided the amount of work is constant. Now in this problem number 4, can dig a pond is dig a pond. This is the constant amount of work. It is saying 12 men can dig a pond in 8 days. How many men can dig it? Dig it means the same pond. So digging the same pond, this is the constant amount of work. Constant amount of work. Here also it will be constant amount of work. So if I consider x as number of men, x to be the quantity x, to represent the number of men, and the quantity y to represent number of days, number of days to dig the pond, then we can clearly see that x will vary inversely with y. Now let's quickly create a table of x and y. So it is given that 12 men can dig a pond in 8 days. So we have the first data, 12 for x and 8 for y. Now it is asking how many men can dig it in 6 days. So let x1 men can dig the pond in 6 days. So we have x1 here and 6 for y. So we have this table. Now we will find x1 using the formula 12 multiplied by 8 is equal to x1 multiplied by 6. So this implies x1 is equal to 12 multiplied by 8 divided by 6. This is 16. So 16 men is required to dig the pond in 6 days. Now as you can see, 12 men were digging the pond in 8 days. Now to find the number of so x1 and if x1 is the number of men required to dig the same pond in 6 days, definitely since 6 is less than 8, definitely x1 has to be more than 12. So we are getting 16. Okay. Problem number 5. 6 cows can graze a field in 28 days. How long would 14 cows take to graze the same field? So this is grazing the same field is the constant amount of work. Constant amount of work in this problem is to graze the same field by the cows. Grazing the same field is the constant amount of work. So you can say x as number of cows, x, the quantity x represent the number of cows, and the quantity y represent number of days required to graze the field. So clearly we can see that if the amount of work is constant, definitely more cows will graze the field in less number of days, and less cows will graze the field in more number of days. So X will vary inversely with Y. So now let's quickly create a table of X and Y. It says that 6 cows can graze a field in 28 days. So we have 6 for the value of X, and the corresponding value of Y is 28. Now it is asking how long would 14 cows take to graze the same field. I am not writing it, I do not have space. So let's say we are assuming X1 cows will be required to graze the same field in 14 days. So we have 14 for Y and X1 for X. So now we can say that 6 multiplied by 28 is equal to X1 multiplied by 14. So this implies X1 is equal to 6 multiplied by 28 divided by 14, and this is equal to 12. So 12 cows can graze the same field in 14 days. Now since always verify whether your answer is coming to be is consistent or not. So if definitely you should check that whether the 14 multiplied by 12 is indeed coming out to be equal to 6 multiplied by 28, and also that X1 is coming out to be 12. Now 6 cows was grazing the field in 28 days. Now if X1 is the number of cows that will graze the same field in 14 days, the 14 has increased, the number of days has been decreased. So definitely the number of cows has to be more than 6. So we are getting 12. Okay. Let's do problem number 6. A car takes 5 hours to reach a destination by traveling at the speed of 60 km per hour. How long will it take when the car travels at the speed of 75 km per hour? So this is an example of a car traveling a car traveling a constant distance at a certain speed and the time taken to travel the distance. So the constant part is the distance. The distance is constant. As you can see in this problem, a car takes 5 hours to reach a destination. To reach a destination. So this is to reach a destination means the distance is constant by traveling at the speed of 60 km per hour. How long will it take when the car travels at the speed of 75 km per hour? That is, how long will it take for the car to reach the same destination at the speed of 75 km per hour? So this is about the speed of a car, the time taken to cover a certain distance, and the distance is constant. So you can say X to be the speed of car, Y to be the speed of car in kilometer per hour, and time taken with the quantity Y to be time taken by car to cover a certain distance. In this problem, it is to reach a certain destination. The destination is same, to cover a certain distance. So every time the car you are changing the speed, so you are changing the speed, the speed of the car is changing and the time taken to reach the destination is changing, but the distance of the destination is remaining constant. So in this case, now we can say that X and Y will vary inversely. So when the distance covered is remaining is kept fixed, then the speed of the car and the time taken to cover that distance with that speed, these two quantities are always inversely related. So if we we plot some data, create a table. So it is given that the car takes 5 hours to reach a destination. Now time taken by a car to cover a certain distance, this is in hour. So from the first data that the car takes 5 hours to reach a destination by traveling at a speed of 60 km per hour. So from the first set of values we get 60 for x and 5 for y. Now it is asking how long will it take when the car travels at the speed of 75 km per hour. Let us assume that the time taken by the car to reach the destination be y1 when it is traveling at a speed of 75 km per hour. So we enter the data 75 for x and y1 for y. And now applying the formula, we can say that 60 multiplied by 5 has to be equal to 75 multiplied by y1. So this implies y1 is equal to 60 multiplied by 5 divided by 75. Okay, so this is 5, 15 and 4. So this is equal to 4 hours. So the car will take, when the car is traveling at a speed of 75 km per hour, it will take 4 hours to reach the same destination. Now you can see that when the car was traveling at 60 km per hour, it was taking 5 hours. Now if the car is, when the car is traveling 75 km per hour, the speed has increased. Definitely the time taken will be less. So we are having answer 4, and 4 is definitely less than 5. Okay, let's do problem number 7. A factory requires 42 machines to produce a given number of articles in 56 days. How many machines would be required to produce the same number of articles in 48 days? So this is also a kind of machines, on a certain number of machine is doing some work and the time taken to do that work. Now the amount of work is constant, which is to produce the same number of articles. This is the constant amount of work. Constant amount of work done by the machine. By a certain number of machines, constant amount of work. This is similar to a men, work and time. Instead of men, in this problem, we are having machines. So a certain number of machines is doing the same work, which is to produce the same number of articles, and it is taking a certain time, that is a certain number of days. So if we say that the data quantity x represent the number of machines, and the y to be the number of days, for machines to produce the same number of articles, then you can realize that these two data quantity will be inversely proportional to each other. So if the number of articles to be produced is same, then if you increase the number of machines, definitely they will take less number of days, and vice versa. That is, if you take less number of machines, the more they will take the number of days. So if we now create a table of data, so it is given that the factory requires 42 machines to produce a given number of articles in 56 days. So we have 42 for x and 56 for y. Now it is asking how many machines would be required to produce the same number of articles in 48 days. So let's say we are assuming x1 machines will be required to produce for the same number of articles in 48 days. So we add the data x1 and 48 for x and y in the table. So now we can say that 42 multiplied by 56 is equal to x1 multiplied by 48. This implies x1 is equal to 42 multiplied by 56 divided by 48. Okay, so 8, 7, 8, 6 and 6, 7. So this is 49. So 49 days, 49 machines, 49 machines will be required to produce the same number of articles in 48 days. So you can see that to produce the same number of articles in 56 days, 42 machines were required. Now, to produce the same number of articles is in 48 days, which is less than 56, obviously we need more machines. That is the reason we are having 49 as the value of x1. Okay, let's do problem number 8. 8 taps of the same size fill a water tank in 27 minutes. If 2 taps go out of order, how long would the remaining taps take to fill the tank? Now, this is also a kind of the same, the problem, the pattern is same, that is men, work and time. That is, in this problem, instead of men, we are having a certain number of taps and they are of same size. And what is the constant amount of work? The constant amount of work is to fill a water tank. The tank is same. This is the constant amount of work, that is filling a tank whose volume is not changing. Constant amount of work is to fill a certain to fill a water tank of a certain volume. So constant amount of work. This is the constant amount of work, that is filling a water tank of certain volume. So we can see that we can consider the quantity x to be the number of taps. Now it is also important that the taps are of same size. Number of taps of same size, and the quantity y we can consider as time taken to fill the tank Now this you can consider in minutes, since it is given that 8 taps takes 27 minutes to fill the tank. So we can clearly say that x varies inversely with y. Now let's tabulate some data. Let's create the table. So always this is the standard way of solving this kind of problem. First you identify the quantities, the relevant quantities which are to be considered for inverse or direct variation, and then you create the table, and then you identify whether the quantities are in direct variation or in inverse variation, and then you create the table, and whatever the question is asking, you assume that to be the unknown in the table, and then you apply the formula of indirect or inverse variation to solve the unknown. So let's create the table. It is given that 8 taps is filling the water tank in 27 minutes. So 27 will be the value of y and 8 will be the value of x for the first corresponding values. Now it is asking how long would the remaining tap, so if 2 taps go out of order, which means now we are having 8 minus 2, 6 taps. So 8 minus 2, which is equal to 6 taps, is now working. Then how long would the remaining taps, that is 8 minus 2, 6 taps, take to fill the tank? Let's assume that the remaining tanks, which is 6, will take y1 minutes to fill the tank. So now we can say 8 multiplied by 27 is equal to 6 multiplied by y1. So this implies y1 is equal to 8 multiplied by 27 divided by 6. This is 3 to 3, 9 to 4. This is 36. So 36 minutes. So 6 taps will take 36 minutes to fill the tank. Now clearly, if you decrease the number of taps, then obviously the time taken to fill the same tank will be more. and that is the reason we are having 36 minutes as the answer, because this time 36 minutes is the time taken to fill the tank by six taps, and earlier when the number of taps was 8, the time taken was 27 minutes, which is less than 36. Okay. uh, Question 9 is very similar to the similar pattern. So 7 taps of the same size fill a tank in 1 hour 36 minutes. How long will the 8 taps? Now in the previous problem, the unit for time taken we considered as minutes, because the data it was given that the 8 taps of the same size fill a water in 27 minutes. The given data was in minutes. So that is the reason we consider the unit of y, that is the time taken to fill the tank, to be in minutes, and the answer was also in minutes. But in this problem, problem 9, it is given that 7 taps of the same size fill a tank in 1 hour 36 minutes. Now you can regarding the time taken, you can consider the unit to be in minutes or in hours. I will consider to be in hours. So whenever the time is given in hour and minutes, always try to convert that time in hours. So this is a very similar problem to the previous one. Let's directly so what is 1 hour? Let's uh, calculate what is 1 hour 36 minutes as hours. So this is equal to 1 plus 36 by 60 hours, which is equal to 1 plus, if we simplify 36 by 60, that is 6 by 10, 3 by 5. 36 by 60, I hope, is 3 by 5. Now, if I am doing any kind of calculation mistake in doing multiplication and finding the answer, that could be a possibility. Please ignore it. My main focus is to understand the problem correctly and applying the concept to solve the problem based on the given data. In finding the final result answer, there is a possibility that I will do any kind of calculation mistake. So please ignore that. So 1 hour 36 minutes is 1 plus 3 by 5 hours, which is 8 by 5 hours. Now let's create the table, or let's say x denote the number of taps. So this problem is very similar to the previous one. The only difference is that this time the time is given as 1 in hour and 36 and hour and minutes, and we are considering the time taken to be in hours. So x will be the quantity x will represent the number of taps, and the quantity y will represent the time taken by the taps to fill the tank in hours. So it is given 7 taps of the same size fill a tank in 1 hour 36 minutes. So we have the value 7 for x, and the value 1 hour 36 minutes is equal to 8 by 5 hours. So 8 by 5 for the value of y. Now it is asking how long will 8 taps of the same size take to fill the tank. So we will have 8 for x, and let's say we assume that 8 taps will fill the same tank in y1 hours. So now we can say 7 multiplied by 8 by 5 is equal to 8 multiplied by y1. So this implies y1 is equal to 7 multiplied by 8 divided by 8 multiplied by 5. 8 cancels. This is 7 by 5 hours. Now 7 by 5 hours, since in the problem the time was given in hours and minutes, it is recommended that you also find the answer in as hours and minutes. So we have the answer y1 is equal to 7 by 5 hours. Now 7 by 5 hours is 1 plus 2 by 5 hours. This is equal to 1 hour plus 2 by 5 into 60 minutes. This is equal to 1 hour and 1 hour and 24 minutes. So 1 hour, sorry for my very congested solution, I hope you can make it out. So a y1 is equal to 1 hour and 24 minutes. Now earlier, when there was it takes 1 hour 36 minutes for 7 taps to fill the tank. Now if the number of taps is 8, then definitely it will take less time, and hence we are getting 1 hour and 24 minutes. Okay, problem number 10. A farmer has enough food to feed 28 animals in his cattle for 9 days. How long would the food last if there were 8 more animals? So this is uh, a special this problem is based on the men and provisions. Instead of men, here we have animals, and instead of and the provisions generally means, I guess, I am not sure, I hope the provisions means food required for men to survive, or in this problem cattle. So it is given that uh, so in this problem, so there are animals and they need food to survive for a certain number of days, and the amount of food is the constant part. So a farmer has enough food. This food is the constant provision. Remember that in a provisions and mean and provisions, the amount of provisions is a constant, it is constant. So for a constant, so if the amount of provisions is constant, then the number of men and the number of days that the provisions last, these two quantities are inversely proportional. So this is the constant provision. Constant provisions, and instead of number of men, we are having the number of animals, and the number of days is the same. So if you consider x to be the number of animals and quantity y to be the number of days the provisions, or for this problem the food lasts, then clearly x will vary inversely with y. But remember that the amount of food is constant, it is kept constant. So if there are more number of animals, they can survive for less number of days, because per day more food will be consumed, and hence the food will last for less number of days. And if the number of animals is less, then per day less food will be consumed, and hence the food will last for more number of days. So now if I create the table of x and y, it is given that a farmer has enough food to feed 28 animals in his cattle for 9 days. So 28 is the value of x and 9 is the value for y. Secondly, okay, so it is now asking how long would the food last if there were 8 more animals. So 8 more animals means 9 plus 8 plus 9 plus 8, which is equal to 17. Let's assume that the food will last for x1 number of days when the number of animals is 17. So we must have 28 multiplied by 9 is equal to x1 multiplied by 17. So this implies x1 is equal to 28 multiplied by 9 divided by 17. For 9 days. Okay, how long would the food last if there were 8 more animals? 17. 3. How long would the food last if there were 8 more animals? I am wondering that 28 multiplied by 9 is not exactly divisible by 17. and the number of days, the answer, that is x1, should be in integer. I mean, it cannot be a fraction. I don't know, it can be fraction. It is strange that the value, what is, so this is 14 into 2, 3 into 9. No, definitely this is not divisible by 72, 25, 252 by 17, it is coming days. I don't know. Now, if you express it as a mixed fraction, it will be 1, 8, 4, 10 by 17 days. I'm not sure about this, but my answer is coming out to be a mixed fraction. So anyway, let me quickly check once again if I did it correctly or not. So a farmer has enough food to feed 28 animals in his cattle for 9 days. Okay, 28 animals and 9 days. Okay, how long would the food last if there were 8 more animals? So 8 more animals. Oh, sorry, 8 more animals. How long would the food last if there were 8 more animals? I did it completely wrong. I'm really sorry. Where is my mind? Okay, so it is saying that how long would the food last if there were 8 more animals? So 28 plus the number of animals is now 28 plus 8, which is 36. And let the number of days, if there are 36 animals, then let the food will last for y1 days. So now we can say 28 multiplied by 9 is equal to 36 multiplied by y1. So this implies y1 is equal to 28 multiplied by 9 divided by 36. This is 4, 7. So 7 days is the answer. Y1 is 7. So 7 days. So clearly, if you increase the number of animals, definitely the food will last for less number of days. So we are having y1 as 7 days, which is less than 9 days. Okay. Question number 11. A garrison of 900 men had provisions for 42 days. However, a reinforcement of 500 men arrived. For how many days will the food last now? So it is the case of, it is a similar problem based on men and provisions. So in this had provisions, the provisions is constant, that is the amount of food is constant. So if we consider x as the number of men, and y as the number of days, uh, the number of days the provisions last, that is the provisions, that is the amount of food is constant. It is given that 900 men can survive on that provisions, that is, which is a constant amount of food for 42 days. Now, however, a reinforcement of 500 men arrived, that is, an extra 500 men has arrived. So, for how many days will the food last now? So, we have to find basically, so how long will the food last when the number of men is 900 plus 500, which is 1400. So definitely we can say x will vary inversely with y. Now let's create the table x, y. It is given that 900 men, based on the constant amount of provisions, 900 men, the provision with when the number of men is 900, the provision is lasting for 42 days. Okay. Now 500 men has arrived, that is now the number of men is becoming 900 plus 500, which is 1400. Now let's assume that now the food will last for y1 days. So we must have 900 multiplied by 42 should be equal to 1400 multiplied by y1. So this implies y1 is equal to 900 multiplied by 42 divided by 1400. So 14 divides 42 with 3. So this is 27. So y answer is 27 days. Definitely, if there are more men, the food will last for less number of days. So earlier the number of men was 900 and the food was lasting. The food means the provisions was lasting for 42 days. Now the number of men has become 1400 and it is now the food is lasting for 27 days. Okay. Question number 12. In a hostel, 75 students had food provision for 24 days. So this is same kind of problem, that is men and provisions. That is, a certain amount of food is available for certain people, certain number of people. Now that people could be students, it could be a men of garrison, or it could be even some animals, farmer. Okay, so in a hostel, 75 students had food provision for 24 days. If 15 students leave the hostel, for how many days would the food provision last? Okay, so let's say X is number of students, and YB, remember that had food provision, this is the constant provision. This is the constant provision. This is the constant for the example of men and provision. Remember that the amount of provision is constant. In this example, the food available in the hostel is the constant provision. Okay, so we have this. So X is the number of students and Y number of days the food in the hostel lasts. So definitely X will vary inversely as Y. So let's create the table X and Y. It is given that 75 students had food provision for 24 days. So 75 students and 24 days. Okay. Now it is asking, if it is saying that if 15 students leave the hostel, now for how many days would the food provision last? So let's assume that when the number of students is 75 minus 15, which is equal to 60, the number of days the food will last is y1. So we can say that 75 multiplied by 24 is equal to 60 multiplied by y1. So this implies y1 is equal to 75 multiplied by 24 divided by 60. So 12, 5, 12, 2, 5, 5, 15, which is 30 days. So if the number of students is less, definitely the same amount of food will last for more number of days. Earlier the number of students was more, 75, the food was lasting for 24 days, and now now the food, when the number of students has become less, that is 60, the food is lasting for longer number of days, for a more number of days, that is 30 days. Sorry. A school has 9 periods a day, each of 40 minutes duration. A school has 9 periods a day, each of 40 minutes duration. How long would each period be if the school has 8 periods a day, assuming the number of school hours to be the same? So this is the constant part. Number of school hours is the constant part, is the constant. This is constant, this is a constant. So the the total number of hours that the school is having periods, the school is having periods is same, is that is fixed, it is not changing. So now if we consider the quantity x to be number of periods, this is another good example of inverse variation. Number of periods and the quantity y to be the duration of each period. Duration of each period. Now, certainly, if the total school hours is kept constant, then if the number of periods is more, then definitely the duration of each period has to be less. And similarly, if the number of periods is less, then the duration of each period has to be more, so that the total school hours is kept constant. So we clearly see that x and y are varying inversely with each other. Now let's create the table x, y. Duration of each period, you can consider the unit as minutes, because since it is given that 9 periods a day, a school has 9 periods a day, each of 40 minutes duration. Okay, so we can say x 9 and y 40. Now it is asking that how long would each period be if the school has 8 periods a day. So if when x is 8, uh, let's say the duration of each period is y1 minutes when the number of periods is 8. So we should have 90 multiplied by 40 is equal to 8 multiplied by y1. So this implies y1 is equal to 9 multiplied by 40 divided by 8. This is equal to 45. So 45 minutes is the answer. That is, when the number of periods is 8, which has decreased from the previous value, that is when the number of period was 9, the duration of each period was 40 minutes. Now if you decrease the number of periods, the duration of each period will increase. So we are having 45 minutes, which is more than 40 minutes. Okay. So question number 14 and 15 are more of these are not word problems, these are conceptual problems. So it is given that the quantity x and y are varying inversely with each other. So mathematically it is expressing the fact that x varies 1 by y, means x and the quantity x and y are inversely proportional to each other. And it is given that x is 15 when y is 6. Find y when x is 9. So basically you can create a table x and y. It is given that when x is 15, y is 6, and you are asked to find y when x is 9. So if x is 9, let's say the value of y be y1. We have to find y1. So we can now say that 15 multiplied by 6 should be equal to 9 multiplied by y1. So this implies y1 is equal to 15 multiplied by 6 divided by 9, which is equal to 3, 3, 3, 2, 3, 5, 10. So when the value of x is 9, the value of y is 10. Okay. Problem number 15, if the same problem, similar kind of problem, if it is given that mathematically it is expressing the fact that x is varying inversely with y. That is, they are x and y, the quantities x and y are inversely proportional to each other. And it is given that x is 18 when y is 8. So if you create the table, x is 18 and y is 8, it is asking to find x when y is 16. So let's say the value of x be x1 when the value of y is 16. So now we can say that 18 multiplied by 8 is equal to x1 multiplied by 16. So this implies x1 is equal to 18 multiplied by 8 divided by 16. So 2 and 9. So 9. So the value of x is 9 when the value of y is 16. So these were all the problems of exercise 12b based on uh, inverse variation from the textbook of author RS Aggarwal. So now let's quickly recall what are all the key concepts and the formulas that we have used to solve these problems, and this part is very important. I am stressing it quite enough that you should always revise the formulas and the concepts that you have used to solve problems when you are solving any exercise. You are solving problems from any exercise in your textbook or in a reference book, or if you are giving any mock test at home for any competitive examinations. Always recall, revise the concepts and the formulas used. That will provide a regular revise of all the chapters. Okay, so let's see what do we have, what are the key concepts and formulas used to solve these problems. So the first one is very obvious, that to verify whether a given table of corresponding values of x and y tells whether that the quantity x and y vary inversely or not. So you will be given a table of values of corresponding values of x and y, and you will be asked whether the quantity x and y are varying inversely or not. So clearly we will check whether uh, so I did it wrong, this is completely wrong, I don't know why I did it wrong, this is wrong. So we have to check whether the quantity x and y are varying inversely or not. So definitely we must have x1, we must check whether x1 y1 is equal to x2 y2 is equal to x3 y3. So x1, x2, x3 and y1, y2, y3 are given values. These are all constants in the table, and you will be asked whether the quantities x and y are varying inversely or not. So basically you have to check whether, you have to find the product of all the corresponding values and see whether they are all coming to be equal or not. If not, then you will say that the quantities x and y are not inversely proportional to each other, and if all the product values, if all the products, that is x1 y1, x2 y2 and x3 y3 are coming out to be the same constant, then you will say that the quantities x and y are in inverse variation. Okay. Now this was only one concept that was used to solve all the problems. Now to solve the word problems, you can consider some examples of inverse variation that I found to be new. The first one is the school and periods. So if the total hours of the school is kept constant, that is for constant total school hours, if you consider the quantity x to be the number of periods and the quantity y to be the duration of each period, then definitely the quantity x and y will be inversely proportional to each other. So if you increase the number of periods, the duration of each period will decrease. If you decrease the number of periods, the duration of each period will increase, because the total number of school hours is constant, is same. The second one is taps filling a tank. So we are having a certain number of taps of same size, and they are filling a tank of a certain volume. The tank is fixed, that is, its volume is fixed. Now the quantities involved are the number of taps and the time taken by the taps to fill the tank. So if x represents the quantity number of taps of same size and y represents the quantity time taken by the taps to fill the tank, we can clearly see that these two quantities will be inversely proportional to each other. But remember that the taps are filling the same tank, that is, the tank is having the same volume. The next one is a factory of machines producing articles. So in a factory there are many machines and they are producing the same number of articles. It is important. So factory of machines producing articles. So if the number of articles produced is kept constant, then the number of machines and required to produce that number of articles and the number of days required by those machines to produce the same number of articles, these two quantities will be inversely proportional to each other. Okay. Now the third concept that I thought about is a kind of problem solving. So it is a bit of it is interesting. So if you are given that two quantities x and y are inversely proportional, inversely proportional to each other, that is mathematically it will be said that you will be given that x varies 1 by y, which means that x and y, the quantities x and y are inversely varying with each other. Now, if the quantity x is increased by p%, then by what percent y will increase or decrease? Okay. So then by what percent y will increase or decrease? Now, okay. So what will be x when it is increased by p%? So this is a very standard concept of percentage. Now, value of x, value of x when increased by p%, you must be very clear about this. The value of x when increased by p% is 100 plus p divided by 100 multiplied by x. So this is the 100 plus p divided by 100 multiplied by x is the value, will be the value when the x, if x is increased by p%. So now let's say if we create a table, the initial value was x and y. Let's say the initial value was x and y, and the x, the value of x has been in the new value of x is after when the x has been increased by p%, which means we can say that the new value is 100 plus p divided by 100 multiplied by x. Now let's say the value of y is y1 when the value of x is increased by p%. That is, so we have these two data in the table. So since the x and y, the quantities x and y are inversely proportional to each other, we must have xy should be equal to 100 plus p divided by 100 multiplied by x multiplied by y1. So x cancels out and we see that y1 is equal to y divided by 100 plus p divided by 100. This is equal to 100 y divided by 100 plus p. So the new value, that is y1, is equal to 100 y divided by 100 plus p. Now this is equal to 100 by 100 plus p multiplied by now y. Now first thing, the question has asked whether what will be by what percent y will increase or decrease. Now since x and y are inversely proportional to each other, if you increase x, definitely y will decrease. So definitely we have to find the percentage by which y is decreasing. So the new value of y1 is this. So amount of decrease, amount of decrease will be equal to y1 minus y minus y1. So definitely y1 will be less than y. So, and by how much y1 is less than y? It is y minus y1. So this is equal to y minus y1 is 100 by 100 plus p multiplied by y. If you take y common, we get 1 minus 100 by 100 plus p. This after simplification will be, okay, so let's do it, 100 plus p minus 100 divided by 100 plus p. 100 plus p minus 100 divided by 100 plus p. So this is equal to 100 cancels out. So p y by 100 plus p. Okay, so this is the amount by which the new value has decreased from the previous value. That is, y1 is less than y by how much? By this much. So now we have to find the percent of decrease. Therefore, percent of decrease is equal to the decrease amount was p. The decrease amount was py by 100 plus p, and this decrease amount is based on y. So divided by y multiplied by 100, this much percentage. So this is equal to py multiplied by 100 divided by y into 100 plus p, this much percentage. This is equal to y cancels out, this is 100 p divided by 100 plus p, this much. By this percentage, the value of y will decrease. So this is an important concept, which is a very conceptual problem. So you are given that the two quantities x and y are inversely proportional to each other, and if x is increased by p%, then by what percent y will increase or decrease. Now definitely, if you increase x, y will decrease. If the question was if x is decreased by p%, then definitely y would have increased. Now in this problem, if for this problem, the value of y will decrease by this percentage, which is 100p by 100 plus p. So this is a very conceptual problem. As an exercise, you can try to solve the same problem when it is given that x is decreased by p%. So I will end the video here. I hope this video will be beneficial to you for understanding the concepts of inverse variation and how to solve the word problems, to identify the quantities involved in the direct or in the inverse variation, and to figure it out that the two quantities are indeed in inverse variation or not, and to solve some standard variations of problem. So if this video was beneficial, please like it, share it with your friends, and once again, please support me by subscribing to my channel, and do not forget to press the bell icon so that you will be notified by my future videos. The next video will be about solving the objective questions from the textbook, which is exercise 12C from the textbook of author or RS Aggarwal. And then I will also provide a homework problems, which will be homework problems number 2, which will be based on both the direct and inverse variation. So please stay tuned for these two upcoming videos, and also keep an eye on the other playlist, that is Maths 8 Hot, where I come up with relatively harder problems on each chapter as and when they are completed in this playlist, that is Maths 8 RS Aggarwal, CBSE Maths 8 RS Aggarwal. So that is all for this video. Thanks for watching, and until the next video, take care and bye.